So no guarantee that they won't burst in.
Okay.
Okay. We're live and kicking by the look of it. And everything seems to be fine and dandy at my end, and my levels are good, hopefully not too good. And I can hear you and I can see you, and that's all good too.
Yep, I should have levels as well.
You do have levels. We all have levels. I tend to stay on the lowest possible level.
We know that.
It's all
you
happening.
and me both.
So we're all good for microphones. Mike, I've got the Rode mic. I've got the Logitech webcam.
Yep. Me too. D camera. That's what I've got. I'm in good shape.
Okay. Yes, all good. All right. Well, let's record the TikTok to get started. And here we go in 3, 2, 1. Hi there. Thanks for joining us. Well, I hope you do very, very soon for the next episode of Space Nuts, the podcast. I'm Andrew Dunkley, your host, and joining me every week is Professor Fred Watson, astronomer at large. What are we talking about this week, Fred?
We've got an action-packed show, as always, Andrew. We're going to talk about more observations that suggest that dark matter is not what we think it is. And we're also going to talk about a new supercomputer that we've got here in Australia. And I'm going to explain why I'm wearing this high-vis vest.
Yes, I'm wondering about that.
Latest in fashion.
It's not a good look.
What? Wait till you see what it is.
Okay, all right, we'll do. We'll also be answering some audience questions, but Fred doesn't know what they are. We're going to do a bit of a potluck on him this week. He doesn't like it, but once in a while it's fun to see how things pan out. So I hope you can join us for the next episode of Space Nuts on your favorite podcast distributor, and we'll chat to you then. All right, that went nowhere according to plan, but that's fine.
That's right.
Now I've got to get over to the media side of things and hit the live button and hope it doesn't cause absolute pandemonium. We do not have any audio questions today, which might make life a little bit easier.
Yeah, technically probably.
And if I can't get the links to work, we'll just go without them and drop them in later, which is what we did last week.
Okie dokie. That's all good.
All right, let us begin in 3, 2, 1. Hello, once again. Thank you for joining us. This is Space Nuts. My name is Andrew Dunkley, your host. And coming up on episode 317 of Space Nuts, we're going to be looking at dark matter because there's a new theory that could change the way we consider it. It might change things significantly if it turns out to be true. But how do we know that? We're also going to look at Australia's newest supercomputer. Yes, it's Windows 3.1, maybe. You might have heard about this story during the week. The James Webb Space Telescope image of a star turned out to be something other than. And Shaun the Sheep is going to join the Artemis 1 crew. Is that right? Or the project or something like that. Now, when it comes to this week's questions, something a bit different. Fred has no idea what we're going to ask him. I've picked a few choice text questions that have been sort of sitting under the radar. So Fred is going to be suitably surprised when it comes to question time later on this edition of Space Nuts.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2. 1,
2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
And here he is, the man himself, Professor Fred Watson, astronomer at large. Hello, Fred.
How are you doing, Andrew? Good to see you again.
Yeah, good to see you too in your high-vis outfit. What the heck is going on there?
Well, look, I'll give it away. I don't know whether you can see the insignia on this.
Yes.
the Sophia aircraft.
Oh,
So
yeah.
this is a high-vis vest that's given to observers and crew on the Stratospheric Observatory for Infrared Astronomy, which is called Sophia, which you and I have covered many times. And sadly, the news is that it's going to be wound back.
Yeah.
So this is going to be a collector's item, and I have it courtesy of my colleague Stuart Ryder, who has observed on Sophia a number of times. And he was with us for brunch on Sunday this week, and he said, well, I've already got a high-vis Sophia vest, and they gave me another one.
Wow.
So I thought you'd like it. So there you go.
Yeah,
I'm
that's
very honoured and proud to have it.
And for those who aren't quite sure what we're talking about, Sophia is the observatory that sticks out the side of a jumbo 747.
It does.
Boeing
There it
jet.
is.
Yeah,
747 SP with a hole in the back.
that's it. And they're decommissioning it, sadly.
Yes, it's very sad as to what's happening.
But that looks rather swish.
That's
Now
not
that I
what you
see the
said
logo.
before, Andrew.
Oh, no, I was just talking about the colours.
I'm going to going to have to stay. Take some clothes off. I'm getting a bit warm in here.
Yeah, of course.
Off and back to normal service. There you go. Back to
All
the
right,
Icelandic
that's-
jumper.
Yeah. Oh, dear. Yeah, we're pretty close to Iceland, or at least it feels like it here at the moment.
It does, yeah. This came from Reykjavik, and it's very warm.
Ah, right. Now, the other thing we wanted to mention before we got into our topics today, you wanted to shout out to Heidi in the US?
I do, because Heidi, somebody I met, she is a space medicine expert as well as a doctor, met actually at a conference of anaesthetists where we were both presenting on space medicine. I was doing the space and she was doing the medicine. There's an astronaut there as well. It was a fantastic meeting. But I haven't heard from Heidi for, 3 years, and was delighted to receive a text that said, "Hi Fred, Heidi de Block here. We met in Malaysia. I am a devotee of Space Nuts and was listening to today's episode. And lo and behold, my birthday was on June the 29th. I was... You made my day." So that's because it was the shortest day, 1.59 milliseconds shorter than any other of the normal 29th of June. I'm just going to read a little bit more because it's really nice to hear from Heidi. She says, "You and Andrew enlivened my drive home from the hospital. I'm glad to hear that you both survived COVID and that Marnie and the cat are well." And then she goes on to say, "One other thing for the podcast. You mentioned life being spread via planet to planet, etc. I was dying for you to mention one of my favorite words, which is lithopans."
Oh, of course.
Yeah, rocks
It-
carrying life.
Yes.
Should have used that.
Should have done. Mm.
Yeah.
Yeah.
So,
So you met at a conference of anaesthetists.
Yes.
Did everyone sleep through that one?
Yeah. Oh, yeah. It was a very, very quiet conference. Actually, it was quite funny because I met an anaesthetist there who had been my anaesthetist in a surgical procedure that I was involved with a few weeks before, and she seemed to be interested in my inside as well. Just winding this up, I like this bit very much. I love the podcast, and my Presbyterian minister husband is hooked too. It's so much fun to listen to, and as a listener, I can feel how lovely you and Andrew are, and that you have a special friendship. You guys really shine.
Oh, isn't that lovely?
It's brilliant.
Thank you,
Yes,
Heidi.
it's so nice to hear from Heidi.
Yeah,
and
that's so nice.
especially to have, somebody who enjoys listening to it, especially
Yes,
on the way home
indeed,
from
yes.
hospital. Yeah.
Speaking of anaesthetists, and this is completely off topic, but we were watching a movie the other day called 13 Lives. I don't know if you've heard of it.
No, I
But
haven't
it's
seen
the
it.
movie that Ron Howard made in the wake of those soccer players in Thailand that got trapped in the cave.
Yep.
And they used an Australian anaesthetist who was also a cave
that's
diver
right.
to save
Indeed.
their lives.
Indeed, he was actually virtually at the conference
Oh,
I was
wow.
at, because he was presented with an award by the Australasian Society, New Zealand Society of Anaesthetists, I think it was.
Yeah.
So yeah, he was. He did a little talk while I was there.
Well worth seeing that movie if you can.
Yeah.
I think it was on Netflix, but well worth seeing that movie, 13 Lives. And it gives you, there's a bit of Hollywood spin, but that's okay. But it gives you insight into how very difficult that rescue was and why an anaesthetist was required because of the tight spaces and the amount of water and the time it was going to take to get them out. And the odds of the boys and their coach panicking and drowning were very high. It's quite an extraordinary story. I found myself captivated.
Yeah, I'm sure it will be. Oh, it was a big event, was that? One of the things that had the whole world on edge.
Well, the movie's an epic too. It's about 2.5 hours. But I was riveted, absolutely riveted. All right. Stuck into it, Fred, and we're going to firstly talk about this this situation that's been put up in regard to dark matter halos. And there's a standard model of cosmology that suggests that these halos are a certain way and in certain places, but a new study through a few universities is starting to pour water on some of these ideas.
Well, that's right. It's more that it raises questions that are really interesting and maybe not so easy to answer for the standard model. So yes, you're right. This is a multi-university piece of research. In fact, the lead universities are the University of Bonn in Germany and my old alma mater, the University of St Andrews in Scotland, Scotland's oldest university, founded in 1413. I was there shortly afterwards. So they
cut the ribbon.
Yeah, that's right. They have been observing dwarf galaxies in the Fornax cluster, which is a cluster of galaxies not very far from our own local group of galaxies. Can't remember the exact distance, but they're very, very well studied. And so, as you said at the beginning, the standard model says that galaxies are immersed in a halo of dark matter, which is what holds them together. So, as is well known, if all that you could see in the galaxies was all that there was, namely the stars and gas and dust, if that's all there is in the galaxies, they should have flown apart billions of years ago. And the same with clusters, they should have all drifted off. And so it was during the 1970s that the idea was postulated that there was something called dark matter. That actually idea was much older than that, but it was Vera Rubin's conjecture that galaxies are immersed, each galaxy has its own halo of dark matter, and that maybe the dark matter was the sort of kernel, the seed that actually attracted the hydrogen that eventually formed the stars and the galaxy. So what has happened is that the dwarf galaxies within the Fornax cluster have been studied, and it's in particular the distortions of the dwarf galaxies. Now, our most familiar dwarf galaxies are the two Magellanic Clouds, which are in orbit around our Milky Way. They're being gobbled up by the Milky Way, strung out into long streams of stars, although the two galaxies are still recognized. But that's what happens when you've got dwarf galaxies near big galaxies. They get distorted by this tidal perturbation. But what they've done is they've actually looked in detail statistically at the distortion of these dwarf galaxies, because according to the standard model that says that all galaxies are immersed in a dark matter halo, the dark matter halo should kind of protect them from the distortion by the gravitational pull of other galaxies in the cluster. And that's something that you can analyze. So what the scientists did from these two universities were, and I'm going to read from our good old standby phys.org, their article on this. The authors analyzed the expected level of disturbance of the dwarfs, which depends on their internal properties and their distance to the gravitationally powerful cluster center. Galaxies with large sizes but low stellar masses and galaxies close to the cluster center are more easily disturbed or destroyed. So they compared the results with the observed level of disturbance. So they analyzed the expected level of disturbance and compared the results with the observed level. And actually they used observations made at the European Southern Observatory, actually at their site in Cerro Paranal. You know, Andrew, that's where the VLT is, the 4 giant enclosures of the very large telescope. But did you also know that there was a VST there? And
a very small telescope?
Well, that's what you'd think, wouldn't it? It's not actually. It's the VLT Survey Telescope. So that's what VST stands for. So it's an acronym within an acronym, but it's basically a wide-angle telescope that looks at detailed imagery. And what they've come up with, and this is a quote from one of the authors, the comparison showed that if one wants observations in the standard model, the Fornax dwarfs should already be destroyed by gravity from the cluster center. Ooh. Even when the tides it raises on a dwarf are 64 times weaker than the dwarf's own self-gravity. And not only does she say that is counterintuitive, she says it also contradicts previous studies which found that the external force needed to disturb a dwarf galaxy is about the same as the dwarf's self-gravity. And so what it's saying is that in the standard model, it's not possible to explain this distribution, what you might call the observed morphologies, morphology just being the shape of these objects. The observed morphologies of the Fornax dwarfs in a self-consistent way cannot be explained by the standard model. And you probably can guess where this is going next, Andrew, because we've got an old friend of Space Nuts who is studying this type of fundamental physics, what we call MOND, the modified Newtonian dynamics, sometimes called Milgromian dynamics, because it was Dr. Milgrom who actually who suggested this back in the early 80s, in fact. So MOND is a way of saying that maybe our idea of the way dynamics works, in other words, Newtonian gravity and the forces the way accelerations are linked to forces, that when you look at very low levels of gravity, that breaks down, and that's the basis of the MOND theory. And so what they've done is they've repeated their analysis using the MOND theory, and they get really good agreement with what they see. In fact, Indranil Banik from the University of St Andrews says, our results show a remarkable agreement between observations and the MOND expectations for the level of disturbance of the Fornax dwarfs. It's exciting to see that the data we obtained with the VLT survey telescope allowed such a thorough test of cosmological models. And that's from one of the other authors, Aku Venhola from University of Oulu in Finland. They're among the other co-authors of this study. So it's really interesting stuff, very provocative in a way. We have a champion of MOND in our audience who waves the flag for it. We occasionally talk to him, Peter Verweyen, and it's interesting to see something that actually supports MOND rather than dark matter. Whether the whole opinion of the world of astronomy will give up on the idea of subatomic particles being what constitutes dark matter, and have another look at MOND, which has actually already been ruled out for other reasons. But you never know. Something's going on here that's really interesting.
So obviously the evidence stacks up, and they can back it up with the data. So it raises more questions. I suppose that's what I'm trying to say. Yeah,
the trouble is, so you've got these different bits of information, and this is one of them that are contradictory, because MOND doesn't work. I think it fails to predict actually what you see in the early universe. There's no way that MOND can contribute towards what we call the cosmic web, the way that this scaffolding was built up in the early universe for hydrogen to fall into and form galaxies. So I know MOND has its pitfalls, but so does dark matter.
Yeah.
So we're in a really interesting era, and it's fascinating the way, as cosmology in particular, the study of the universe as a whole and its evolution, as that progresses, how ideas come and gradually shape the view of all astronomers. For example, in the 1970s, we all thought the universe was going to collapse on itself. And then suddenly along came Brian Schmidt and Saul Perlmutter and demonstrated that it's not. Its expansion is accelerating. So
yeah.
who knows where we'll be in a year's
indeed,
time?
who knows? But I suppose this will give them a baseline to work with and move forward with other studies and concepts and experiments to see if they can prove one way or the other what's happening.
Yeah,
and
that's right.
Who knows? We might get an answer to this puzzle one day, hopefully.
Soon.
Yes. All right, let's move on to this next exciting story, because due to the fact that Windows freeware, Australia now has a supercomputer, or is it a stupid computer? I'm not sure. But let's put the jokes aside, because there has been a development involving Australia's newest supercomputer. I didn't even know we had one.
Oh, yes, we do. We have something over in Western Australia, which is called the Pawsey Supercomputing Research Centre, and it's based in Perth. And it's what is used to analyze data from the basically the square kilometre array and ASCAP, the Australian Square Kilometre Array Pathfinder, the Murchison Wide Field Array, MWA, and eventually the Australian Square Kilometre Array itself. And the reason why this is in the news is that there is a new supercomputer which has just been installed at the Pawsey Computing Centre. It's got a nice name, actually, and I'm not sure whether I'm pronouncing this correctly, Cetonix, or Cetonix, or Cetonix. And it's named after... Pardon? Potato. Yes, that's right. Oh, so it could be Cetonix.
Yeah.
Cetonix. It's basically a zoological name, Andrew, because it comes from something else that I'll mispronounce, Cetonix brachyurus, which is the Latin name for the quokka.
Oh.
Yep.
Rottnest Island.
Yeah, that's right. Rottnest Island. They have quokkas there. The quokkas throughout WA. I don't know enough about.
I'm not sure exactly, but yeah, I know they're very common on Rottnest Island, and they're a tourist attraction. Yes,
so they're marsupial rats, marsupial mice. Are they a bit like our Antechinus, or I don't know. I'm not an expert on quokkas.
Me either.
Quokkai, perhaps it should be. Anyway, that's the name of it, and it's it's following the footpaths of so much that happens in Australia, where the name of something new gets called after one of our species, like the huntsman we were talking about last week, the spider. Anyway, this has now been announced as being basically functional. I don't think it's finished yet. I think Cetonix is still a work in progress, but it's on its way to being eventually 30 times more powerful than the supercomputers that they had at Pawsey before. And so it is actually a very spectacular piece of kit. It's part of something called the NCRIS, which is basically a government-funded program, National Research Infrastructure scheme. I think it was the S, can't remember, but that's a way of government funding going into things like these laboratories and computers. And the reason why it's, and I hope our listeners might follow up on this on the web, because if you check out Cetonix on the web, it should take you, as well as to a picture of a quokka, to a very spectacular image of a supernova remnant, which has been imaged by ASCAP, the Australian Square Kilometre Array Pathfinder. And these data have been analysed by the Cetonix and produced a that is really very suggestive of what a supernova remnant is, which is basically an explosion. So when a star goes supernova, it sends out shock waves, which
Oops. Fred has frozen. This has happened to us a few times in recent months, which is infuriating, but I'll send him a message.
and I'm not sure whether I've lost you, Andrew.
You're back now.
Okay.
Yeah, you just froze mid-sentence, and I was just going to message you to say that you
Okay.
froze. I can hear your voice, but I've got no movement on the camera.
Can you still see no movement, or
No, your image is still at my end,
yeah,
and now it's gone completely.
that's not very good.
No,
I've
it's not, is it?
got a signal on the Optus modem here that says it should be okay. Gosh, we've not had an easy run today, have we?
No, we've had some issues before we even started.
Yeah, that's right. I'm just doing another speed check to see what's happening.
Okay.
I thought I was in good shape here.
Yeah, I did
checked it a
too.
minute or two ago. Well, I've got a decent download speed. It's probably the upload giving the trouble. It does say the actual recording is of higher quality than we can see. Not doing anything. That's probably good news.
Yeah.
Upload. Yeah, the upload has dwindled away. I've no idea why that should be, Andrew, but I've got virtually nothing here.
Oh, yeah, I can see it's slowed down in terms of.
That's crazy. Why has that happened?
So that's on the other modem.
It's on the modem, yeah.
That says to me that the issue is more of a hardware issue outside of the house.
Yeah, maybe.
If you use two different modems with the same problem, through two different suppliers, so ISPs, it's got to be the. Yeah, I don't know what it is. I'm no expert.
Neither am I. Just annoyed, really. Let me check it again. What's odd is I've got decent download speed, but it's my upload that's not functioning. Maybe I should have rebooted the computer at the beginning, which I think you suggested.
Well, I mean,
can we keep going, or
So Hugh's telling me there's an image of you there, and the listeners are saying he's okay. So I'm the only one that can't see you. So let's carry on. Let's carry on.
If it's only you, that's fine.
Yeah, I know what you look like.
Yeah, still got very poor upload though, which is a bit worrying. Anyway, never mind. All right, thank you, listeners. It's great that there are people out there telling us what's going on.
Yes,
more than we know.
So we just need to wrap up that segment.
Yeah.
I'm just trying to remember where you were up to when we got.
So I threw to you because I just finished talking about the supernova remnant, Andrew. So it really just needs you to make a profound comment about.
See, I've got a profound comment ready to go. Here we go. All right, we'll pick it up in 3, 2, 1. And Fred, it doesn't surprise me when I heard you say there was government funding. Of course, they would have to wait until Windows 3.1 became freeware so that we could afford it, which is good.
There you go. Yes.
But fascinating image of that supernova remnant. If people want to have a look at it, you can check it out on the Cosmos magazine website. But I'm sure you'll be able to find it in many other places.
Should be
and and check out what a quokka is too while you're at it. QUOKKA, I think is how you spell quokka. Yes, it is. Yeah, funky little creatures they are. This is Space Nuts with Andrew Dunkley and Professor Fred Watson. Right, we survived.
Nearly.
Sort of.
Just looking up a quokka as well.
Excuse me. Yeah, your upload is dwindling.
Ah, dear. Is it? Oh, yes. Look at that. Where am I? 79%. Yeah.
Yeah,
Dear.
gosh. What a pain.
Mm.
I just heard the grandchildren arrive, so we'll probably get interrupted.
All right.
We mightn't. Judy will
This
lasso
might be
them
a
if they
short,
head this way.
might be a short show, folks.
Could be. Could be.
Yeah.
All right, let us carry on and move on to the next topic. We'll do that in 3, 2, 1.
3, 2, 1.
Space nuts.
Now, Fred, this is a story that's sort of captured a lot of people's imaginations and caused a few smiles and probably a little bit of embarrassment in some quarters, involving a French scientist who purportedly released a wonderful image of a star from the James Webb Space Telescope, but it wasn't a star. In fact, he no longer feels like a star because he's been forced to apologize. What on earth has happened here?
So indeed, so this is a gentleman by the name of Etienne Klein, who is the director at the French Atomic Energy Commission, so a scientist of a senior level, and he put a picture on Twitter, which he said it's a photo. I'm trying to translate from the French here. Photo of Proxima du Centaure, the star closest to the sun, situated at 4.2 light years from us. It was taken by the JWST, a new world for something. Oh, for yes, something to do with day after day, jour après jour. I'm not sure what I'm reading there, but anyway, it's fine. So it's a star. It looks like a reddish star, and of course, Proxima Centauri is a red dwarf. It's pretty well what you might expect Proxima Centauri to look like.
Yeah.
Except when I looked at it, I said that is not a star, and that's because it doesn't show any limb darkening. And I don't know whether you and I have ever talked about limb darkening, Andrew. You can see it.
I don't recall it.
See it on images of the sun. The limb is just the edge.
Okay.
And so if you look at a picture of the sun, just taken in ordinary white light, ordinary visible light, you'll see it's darker towards the edge of the picture. And that's because you're looking through a thicker layer of atmosphere, essentially. On the sun. So that's a term known as limb darkening. It's well known to astronomers, and stars do it too. But this one doesn't, because it is a picture of a slice of chorizo sausage, Spanish sausage.
You know,
So,
I don't know about the finer details when it comes to these kinds of images. So when I saw it, and read the headline, I saw the star before I realized what was going on.
yes.
And so it completely duped me. Personally, I think it's hilarious. I think it's funny.
It's great.
And you know, I love people who enjoy having a bit of fun, and it's not harmful fun. But he has been forced to apologise for his indiscretion.
He does. He has too. That's right. I mean, you know, what I like is people who don't take themselves too seriously in science. You've got to be there are times when you have to have the utmost seriousness, but there are times when you can perhaps not to be. Unfortunately, as you said, kind of a bit of criticism from Twitter. I've just realized that the thing I was trying to translate from the French is actually written in English above it.
Right.
A new world is revealed every day. So he got basically criticized by the fact that scientists, we've often got to defend against fake news. We've often got to tell people this is not a real image. There's plenty of them around, and I get them from time to time as well. People ask me about them. And so he he's apologized. He said his aim was to remind people to be wary of arguments from people in positions of authority. I come to present my apologies to those who may have been shocked by my prank, which had nothing original about it, he tweeted.
Maybe
yes.
it would have been more acceptable had he done it on the 1st of April.
Yes, that would have been better. That's right. He should have waited. Somebody tweeted, coming from a scientific research director, it's quite inappropriate to share this type of thing. You can see that, but
I guess so.
Yeah.
From my perspective as somebody who likes a great prank, I thought it was fun. I enjoyed it.
Yes, I did too.
It reminds me of the BBC's Great April Fool's Day joke of the spaghetti harvest of Switzerland, I think it was. And it was done on the BBC's Panorama program back in the 50s.
Right. Yeah.
And it was so convincing because people didn't know much about overseas cuisine in those days.
No.
You're stuck with your bangers and mash in the UK. So right. When they found out they were being duped about all this spaghetti growing on trees and the spaghetti harvest and the narrow window of opportunity to do, they were absolutely furious that Panorama would do something like that. So I can understand why you'd get a bit upset because from their perspective, Panorama was a serious show. You didn't do that. So that's kind of what's happened here.
I think that's right. Yes. Yeah. That's right. We've come a long way since Panorama in the 1950s, but maybe not quite far enough for this sort of thing.
It still stands up as the greatest April Fool's Day joke in history. You can watch it on YouTube.
Yes.
So it's worth a look. But this one, not bad at all. I'll give him a 7.5.
There you go. It's got the Andrew Dunkley seal of approval.
Yeah, I'd give him 10 out of 10 if he timed it better.
Yeah. 1st of April would have done it. That's right.
Yeah, but it's a very convincing picture for those of us who don't know what to look for in the image of a star. So well worth checking out. This is space. Oh, no, we've got one more thing. Sorry. Let's move on to the next. So many topics. I wasn't. We're usually going to do one per segment, but we've got another one. Sean the Sheep is going to be a crash test.
Well, he's not actually. He's going with a crash test dummy, which also has a name actually. It's a mannequin, which is on the Artemis mission. Remember, the Artemis we hope will launch before the end of the month, which is the uncrewed version of what we hope the next time will take astronauts around the moon. It's a translunar mission to send the spacecraft around the moon. In fact, it goes 70,000 kilometers beyond the moon. It's going to be quite a serious external extension of the excursion. There you go, 3 X's in a row. But it does already have a sort of mannequin on board, which has accelerometers attached to it and things of that sort. Temperature measurements and all kinds of sensors, radiation sensors. The mannequin is actually named after a gentleman whose name was Arturo Campos, who was the electrical power subsystem manager for Apollo 13 on the lunar module. Wow. So he was the guy who brought the Apollo 13 astronauts back to Earth. At least he was a key player. So they've named him. They've named the mannequin. He's not a mannequin. He's Moonikin. Moonikin Campos is his name. That's the mannequin. But the mannequin has company. It's an ESA, European Space Agency addition to the mission, because ESA is involved with Artemis. And it's Shaun the Sheep, the famous Aardman cartoon character, or what you call it, animation character. That's probably
it's I don't know if you call it claymation. It's closer to an animation.
Yes,
but I'm a big fan.
Yeah. Was it Nick Park? Was that the guy's name who started that stuff up? I'm misremembering.
I couldn't tell you.
Somebody would know. We can probably check that quickly.
Probably.
Man, I think it was Nick Park who who said all that? Oh, gosh, I've got very slow internet here. I wonder why.
Nick Park. Yes,
Yeah.
Nick Park.
That's so I got it right. I thought it was Nick Park. Yeah.
Stop motion animation is what they call it.
That's what.
Yeah.
Animation, yeah. So Shaun the Sheep, a very much loved character who's starred in several movies, I think. It's just apparently it's tradition that you always take a doll of some sort. I mean, it's often been a dinosaur. Even Yuri Gagarin took a doll with him for the first ever human space flight. And,
is that true?
Yeah, he did. And it's the way you demonstrate you're in, zero gravity. Well, you're in effectively weightless, and you're not in zero gravity, but you're weightless. You let the puppet or the doll float. So we might see images of Shaun floating around in the Artemis capsule as he heads off to the moon. And we hope, because this mission will
we definitely hope they come back. Yes.
Yeah.
So if they're going 70,000 kilometers past the moon with this test mission, does that suggest they're going to try the same thing with people on board? And would that then mean that those people will have traveled further from Earth than any other human, or is that a stretch?
No, I think that is planned. Yes, I need to check that. But certainly the uncrewed, it's Artemis 1.
Yep.
Artemis 2,
which I've got my name on, as have
you do. That's
several
right. Yes,
space nuts people.
you've got your name there. So Shaun might read it out or something.
I've got a boarding pass.
And Artemis 2, let's just check the NASA details of that, because we can do it. At least we can when the internet's working. It will indeed. The astronauts on their first flight aboard NASA's Orion spacecraft will travel farther into the solar system than humanity has ever traveled before. And it's to confirm all the spacecraft systems and make sure that everything's going to go. So Artemis 2 will indeed build upon the uncrewed Artemis 1 flight by demonstrating a broad range of the Space Launch System and Orion capabilities needed on deep space missions. It's quite exciting. Yeah, Artemis 2 goes around the moon and does a sort of figure of 8 loop, a little bit like Apollo 8 did, if you remember what happened there. But the details are all on NASA's website, of course.
Absolutely wonderful. And we wish Shaun the Sheep et al. Good luck. And we can't wait for that launch to happen and follow the mission, especially those of us who have got our names on board. That, I think, is really exciting. It's as close as I'll ever get to going to the moon, I think, Fred.
You never know, Andrew. Don't give up.
I haven't. I'm waiting for my invitation. That's why I stay so fit.
Good.
Okay, we'll leave it there, but there'll be more on that story going forward. This is Space Nuts with Andrew Dunkley and Fred Watson. Oh dear. All right, we've had some audio distortion or disturbances during the recording, but hopefully the local recording won't have been affected. So the final product might be okay. All right, let us continue with the questions. We might as well keep going while we can.
Yes, I think so.
Yep. Let me get that lined up. All right, here we go in 3, 2, 1.
Space Nuts.
Now, Fred, it is question time, and normally you and I have sat down and pondered and thought and selected and discarded. No, we don't do that. Questions from the audience. But today, you have no idea what I'm going to ask you.
No, I don't. That's all right.
No, I've got 4 questions from 3 listeners. They're all very short, and some of them are just a bit out of left field, which I thought you would enjoy.
Okay.
All right, this comes from Travis in Auckland, New Zealand. Why do astronomers refer to all the chemical elements heavier than hydrogen and helium as metals?
Metals, because we're dumb, really. It's true. It's so the normal definition of a metal is something that conducts electricity, I think, or some definition like that. Whereas astronomers just have a different definition. It's anything heavier than hydrogen or helium is a metal. because it's not hydrogen or helium. So
These are the same people that photographed chorizo and call it a star. That's
no,
what it is.
he wasn't an astronomer.
Oh, listen to you,
Yeah.
distancing yourself.
Just an atomic scientist, you know. Yeah, it is weird. It's a quirky thing that we really should get, should get real about. But it's and in fact it's embodied in another word that we use. I think I'm going to sneeze, Andrew. Oh no, it's gone. That's all right.
I had that happen on air the other day on the radio station. Couldn't stop it.
No, there are times when you can't. So we talk about the metallicity for example, of a star, because you can work out the ratio between the hydrogen in the star, and then you pick another of the elements, and it's usually iron, in fact, that's used for this. It's the ratio of iron to hydrogen, and you can understand why that then is called a metal, because iron's a metal in both senses, whether you mean astronomical or physical. But yes, the metallicity is how much of heavier elements there are in the star's atmosphere, and of course it's a link to the star's age as well, because the lower the level of the lower the level of metals, i.e. not hydrogen or helium, in the star's atmosphere, the older it is, the earlier in the universe it was formed.
Okay. So they call it a metal because
they do.
Yeah. All right. Thank you, Travis. Next question comes from Scott in Lancashire. As we all know, for some reason, Uranus spins on its side in relation to the sun. Is it destined to stay like that till the end of the solar system, or will the sun's gravity or some other force gradually pull it back around? Thanks for the podcast, guys. You make Thursdays worth looking forward to. Gee, you're easily pleased. Thanks, Scott.
That's a really good question, because it does tend to be the long-term effect of gravity is to try and straighten things up, to make orbits circular and to make things stand up in their orbits and behave. So I think it's possible, but I don't know what kind of timescale we will be thinking about there, in terms of how long that process might take.
Well, I suppose we can analyze Uranus pretty effectively from where we are. Would we not notice if it was starting to straighten up?
Not over the timescales that we've been observing the solar system.
Okay.
You'd be talking millions of years, if not hundreds of millions or billions. That's. Let me just.
Oh, you've got him thinking now, Scott.
Okay, so what I've put in Google is long-term obliquity, because it's the obliquity of its orbit that is in question. I don't know that it's...
Even the great astronomer uses Dr. Google.
Quite so. So it's spin orbit resonance. So here's a paper which investigates whether Uranus's 98 degrees obliquity was a byproduct of a secular spin orbit resonance. In other words, could it have been something other than a collision? Look, I think that there are mechanisms that you can imagine that it would, in fact, make Uranus want to tilt back again, but I'm not sure what sort of lengths of time that we're talking about. Very, very interesting question.
It is.
Should look at that again. I mean, but I don't think there will be any change that we would notice for a very long time, Andrew.
Yeah. So it could happen. It just would be a very longitudinal effect.
A long slope. That's right.
Yes. All right. There you go, Scott. So you're kind of on the money. You're just going to have to wait a little while.
For a while.
Okay, Tom from Stockport in the UK has two questions for us. One, just wondering if black holes and white holes are meant to exist and are supposed to be opposites to each other, what would you think a grey hole would do?
Yeah,
They do
I
exist.
like it.
They're on the moon. They're called craters.
Yeah, I love it. A grey hole. Yes. So we don't know whether white holes exist, and my guess is that they don't. That they're just a quirk of the mathematics that says that they might be able to exist. Black holes definitely do exist. So grey holes.
They're
Well,
just very, very old black holes.
could be. Yeah. Just like the grey nomads who tour around Australia, they might be
Yep.
elderly black holes. There you go.
That could be it.
In
But
Winnebagos.
if there's no white holes, then black holes stay black because they can't mix with the white and turn
Can't
grey.
mix with them. I suspect if you got a black hole and a white hole together, though, it would be quite spectacular.
I imagine it would be.
Yes.
Yeah.
Yes.
That would be a sight to see, but probably no such thing. Black
As a
only.
white hole.
It's
Yeah,
it's
black
like
only.
the Model T Ford. You can get it in any color you like as long as it's black.
That's right.
Hmm. Okay, and Tom's other question. This one is a little bit more serious, but still tongue in cheek. Some people believe the Earth is flat.
Mhm.
So, do they believe that the universe is flat too? If so, would the universe still work in the same way or move in a completely different way or not work at all? Love the show, Tom.
Well, the universe is thought to be flat.
Oh.
In the sense that it's not flat in like a tabletop. It's flat in that its geometry is not curved. In other words, it's the normal geometry that we experience around us, where parallel lines never meet and things of that sort. That is what you get in a flat universe.
Yeah.
A universe with curvature gets all kinds of other things in it as well, like these parallel lines crossing and things of that sort. So yeah, but look, the flat Earth really doesn't have any merit whatsoever. A flat universe does, but it's not. It doesn't mean that it's shaped like a tabletop. In fact, we think the universe is isotropic, which means symmetry. It's the same in all directions.
Okay. So, yes, no point really entertaining this angle of thought, I suppose. But and I don't see how a flat universe would work. It would be, well, the what's the word I'm looking for? The physics would make it impossible.
Yeah, that's right. I mean, the Milky Way is flat. It's a spiral structure in a plane, and you get that just because of the combination of gravity and rotation. That's what happens when you form a galaxy. The spiral structure comes from density waves moving through and basically creating newborn stars. But yes, there's a flat geometry to the Milky Way, and in a way that's made obvious by the fact that we look through the thickness of the galaxy and see the Milky Way itself going all around the sky.
There you have it. All right, Tom, thanks for your question. Great questions. I just plucked them out of obscurity because they've been sort of sitting there a while, and I thought, let's just do them all at once.
Yeah,
and have a bit of fun. It's good.
Absolutely.
Yeah. So thanks, Travis. Thanks, Scott. Thanks, Tom. And don't forget, if you have questions for us, and we could use a few, we're running a bit low for some reason. Maybe people don't want to ask us anything anymore, Fred. But you can send them to us via our website, spacenutspodcast.com or spacenuts.io, and click on the AMA tab to send us a text question or an email question or an audio question. And there's a little button on the right-hand side of the home page where you can send your audio question as well. While you're there, have a bit of a look around, shop around. Astronomy Daily's there. There's the Space Nuts shop, which has all sorts of goodies available to you. Have a bit of a squeeze. And don't forget to check out the supporter page if you want to become a supporter of Space Nuts. There are plenty of ways to do that on our website as well. And please keep sending in your reviews via your favorite podcast distributor. We love your reviews, and they're very, very helpful. They just keep the audience growing. That is where we're going to call it quits, Fred. We got there in the end. Thank you so much.
We seem to have done. It's a pleasure, Andrew. And don't forget your lithopanspermia, courtesy of Heidi de Block.
Indeed.
Thanks, Heidi. And a shout out to everybody out there who likes lithopanspermia like I do.
All right. Thanks, Fred. We'll catch you next time.
Sounds great. See you soon, Andrew.
See you, Fred. Fred Watson, astronomer at large, part of the team here at Space Nuts. And Fred has sent Hugh yet another wonderful editing challenge on this week's episode. And from me, Andrew Dunkley, thanks for your company. And we'll look forward to joining you again on the very next episode of Space Nuts. Bye-bye.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Google Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com.
This has been another quality podcast production from Bytes.com.
And thanks to everybody who watched us live. We had another fun session. So thanks for tuning in. We'll